Good afternoon. Today we are going to be learning about the ratio test. So I went around town and interviewed random people to see how many people really know what the ratio test is. Let's see what they said.
First interviewee, Shauna May Oliver. Shauna, do you know what the ratio test is? Second interviewee, Ginger Oliver. Ginger, do you know what the ratio test is?
Who's here?
Very good, Ginger.
The ratio test is a very easy way to determine whether or not a Taylor or Maclaurin series is going to converge or diverge. It's much easier than the limit comparison test and the comparison test. With the ratio test, you need the general term, u of k, and you also need u of k plus 1. What you have to do is you have to take the limit as k approaches infinity of u to the k plus 1 all over u to the k. And this right here is equal to rho. If rho is less than 1, then the series will converge. If rho is greater than 1, then the series will diverge. And if rho is equal to 1, then the test is inconclusive. So we must use another test. So our first example is k to the k over k factorial. And since we're using the ratio test, we know that rho equals the limit as k approaches infinity of u to k plus 1 all over u to k. So first, we take the limit. So rho equals the limit as k approaches infinity of k plus 1 to the k plus 1 all over k plus 1 factorial times 1 over uk, which is k factorial all over k to the k. And we know that k plus 1 factorial is the same as k plus 1 times k factorial.
Got it?
So this is going to cancel with this and just leave us with k plus 1. And we know that k plus 1 to the k plus 1 is the same as k plus 1 to the k times k plus 1. So this is going to cancel with this, which will leave us with rho equals the limit as k approaches infinity of k plus 1 to the k all over k to the k.
Got it?
Oh, the limit doesn't exist! No.
So we can simplify this to the limit as k approaches infinity of 1 plus 1 over k to the k. And this, we all know, as k approaches infinity, this equals e. So since rho equals e and rho is greater than 1, this series is going to diverge.
Let's try another problem to make sure that we got what's going on. So we'll try k over 2 to the k. We've listed out some terms so that we can see. And so first, rho equals the limit as k approaches infinity. So k plus 1 over 2 to the k plus 1 times 1 over u to k, which is 2 to the k all over k. And we know that 2 to the k plus 1 is 2 to the k times 2. So that cancels with that and leaves us with 2. So rho equals the limit as k approaches infinity of k plus 1 all over 2 to the k. And as k gets infinitely big, this is going to equal 1/2. So rho equals 1/2. And since rho is less than 1, this series will converge.
Let me try.
Kelsey, I got it. I know how to do the ratio test. Rho is equal to 1/2, which is less than 1. So this series converges. I can't believe I got it. Dinner time.